powder method. It is devised by P. Debye, P. Scherer and A. W. Hull. Finely ground crystal powder may be filled into a capillary tube or coated on a hair, and the monochromatic X-rays are allowed to fall only in proper directions. There will be constructive diffraction. The maxima in the diffraction spectrum placed on the photographic plate placed behind the sample, and a circular arc is recorded, the holes corresponding to inlet and outlet of X-rays. The outlet indicates the path of the undiffracted X-rays. So, at this position, the value of 2 theta is equal to 0 degrees and 2 theta is equal to 180 degrees for inlet X-rays. On this basis, the value of theta for different lines on the film are determined. By knowing the lambda of the X-rays, theta determined by the experiment, d values can be calculated from Bragg's equation. Structures of simple ionic compounds. An ionic compound is formed by the electrostatic force of attraction between the oppositely charged ions. If theoretical and experimental thermodynamic properties of a solid are same, then it is an ionic compound. Structures of AB type of ionic compounds are discussed here. 1. Structure of NaCl. This is known as rock salt structure. It has FCC array of Cl minus ions and Na plus ions. These ions occupy all octahedral holes. The coordination number is 6. The structure is said to have a 6-6 coordination. In this structure, the environment of an ion is such that the nearest neighbors of the central ion lie at the corners of the faces of the cells and from the octahedron around the central ion. All these 6 ions have opposite charge to that of central ion. In unit cell, there are 4 equivalents of Na plus and Cl minus ions. In each unit cell has 4 NaCl formula units. For example, lithium chloride, potassium bromide, silver chloride, magnesium oxide and calcium oxide. Structure of simple cubic crystalline compounds. It is a face centered cubic crystal compound. We can find one type of ions on the corners and the other type of ions at the faces, and this is also called as the rock salt structure. Structure of cesium chloride. It is a body centered cubic structure. The coordination number is 8. Chloride ions are at the corners of a primitive cube array and cations occupy cubic hole at the center. Cesium chloride structure has 8-8 coordination. Example, cesium bromide, cesium iodide, copper zinc alloy and ammonium chloride. So, this is the cesium chloride structure. Again, a body centered cubic crystalline structure. We can find the different type of atoms occupying the different positions. One type of atoms on the corners of the cube and other type of atom at the center. The center is occupied by the cesium ion and the corners are being occupied by the chloride ions.